Hey Algebra 1, we are starting a new unit. We are working on Module 1 or Unit 1, however it's labeled, where we're getting into a little bit of statistics. I hope you enjoy it. First of all, let's talk through some information. So statistics is all about data. Without data to talk about or to analyze or to question, statistics would not exist. There is a story to be uncovered behind all data. A story that has characteristics, a story that has characters, plots, and problems. The questions or problems addressed by the data and their story can be disappointing, exciting, or just plain ordinary. This module or unit is about stories that begin with data. So first of all, let's talk about these graphs. We often summarize data with graphs. The graphs are the first indicator of variability in the data. Okay, variability is very important. Our first type of graph is called a dot plot. So a dot plot is a plot of each data value on a scale or number line. So here I have a number line, and each one of these dots represents a piece of data. We're going to look at this one in a second, but here my number line talks about viewer age of who knows what. So we're talking about the age of people that watch things. Each one of these dots represents a person of a certain age. Like right here, I have 3 people that are 10 years old. Here I have 2 people that are 20 years old. Nobody is 70 years old, etc. So each value, each dot is a person or a value on a number line. Another type of graph is called a histogram. This one shows the graph of data that groups the data based on intervals and represents the data in each interval by a bar. So here we have an age, and this right here is a histogram of ages for the country of Kenya. Our age is right here. So everybody who is between 0 and 5 years old, I have 17 people that are between 0 and 5 years old. 15 people that are between 5 and 10. 11 people that are between 10 and 15. I've got, right here would be 1, so maybe 1 person between 65 and 70. All right, so the shaded bar represents the data in each interval. Next, I have a box plot. This is a graph that provides a picture of the data ordered and divided into 4 intervals. 4 intervals, that's the important part. That each contains approximately 25% of the data. So I have 1, 2, 3, 4 intervals. Each one of these contains 25% of all the data, and it is always associated with a number line. So between 0 and 1, that is 25% of the data. Between 1 and 2, this is 25% of my data. Between 2 and 5 point something, 25%. And this is all 25% of my data. That's what's important about a box plot. So let's work through some examples. What's really interesting here is these examples aren't going to have exact answers. Because this is statistics, our answers are more of a discussion or an opinion, but your opinion must always be supported, okay? So here we have transportation officials collect data on flight delays, the number of minutes past the scheduled departure time that a flight takes off. Consider the dot plot of the delay times for 60 Big Air flights during December of 2012. So I have 60 flights here. They're all represented on this dot plot. Each dot represents the delay time of a flight. So 2 flights were delayed 120 minutes or 2 hours. 2 flights were delayed no time, 0 minutes, and everything in between. So first thing we do when we get a problem like this is we look at the data. and we try to see how it's shaped, if there's any crazy outliers or dots that are all by themselves. If we have a big grouping of some dots, we look at everything. We read our labels, we read what the graph represents, and then we look at our questions. So what do you think this graph is telling us about the flight delays for these 60 flights? I see that most flights were delayed about 15 minutes. Okay, that's what I read here. And some were delayed longer. Can you think of a reason why the data represented by this graph provides important information? Who might be interested in this data distribution? Travelers might be interested. If they looked at a certain airline, like Big Air, and they saw that most flights were delayed a ton of time, they may try to find a flight on a different airline. So the travelers would be interested. The airline would also be interested. And why would they be interested? The airline might be interested so that they can track flights and maintenance, or weather. I'm brainstorming now. Certain airplanes, and if they're delayed more than others. Based on your previous work with dot plots, would you describe this dot plot as representing a symmetric or skewed data distribution? Okay, it says here, recall that skewed data distribution is not mound shape. Now that you can read that. Okay, and if you don't have any past history with dot plots, you're learning it for the first time now, and you need to make sure you understand it or ask some questions. So a skewed data distribution is not mound shape, and I would say a mound shape would look, with all the dots in the middle in a mound, right? So based on your past history, this is not mound shape. It sort of has a tail. This is called a tail on the right side. So this is called a skewed graph, a skewed dot plot, because it has a tail to the right. Okay, and your past history on dot plots may tell you that. If not, let's remember that that's a tail. This would be a mound. Can't spell, sorry. This would be a mound, and this is a tail. Okay, let's try another one. A random sample of 80 viewers of a television show was selected. The dot plot below shows the distribution of age in years of these 80 viewers. So what do you think this graph is telling us about the ages of the 80 viewers in the sample? Looks like I've got a lot more people down here. So we can say the typical age of viewers is between 60 and 70. Okay, we're right about there. It's getting a little crowded. Between 60 and 70 years. So the show, I can also just assume that the show appeals to a wide range of viewers, a wide range of ages, right? Can you think of a reason why the data presented by this graph might provide important information? Who might be interested in this data distribution? So if we're looking at the audience, who might be interested in the audience of a show. We could say that maybe some commercials. People who are trying to sell their product might be interested because they're going to market their product to a certain age group, right? And if the product, if the product is more towards 60 to 70 years old, they'd be interested in putting that commercial on during this TV show. So that would be interesting. So yeah, if we're just trying to understand who's watching, so they know who to market commercials to. So based on your previous work with dot plots, would you describe this dot plot as representing a symmetric or skewed data distribution? Explain your answer. Again, a symmetric one is one that's in a mound, and here it looks like we have a tail to the left. So this is definitely not mounded, not symmetrical. Let's look at a histogram. The following histogram represents the age distribution of population in Kenya in 2010. We have age in years. This is percent of the population. I thought that was number of people when we looked at it earlier. That's silly now that I think about it, but it's percent of population and how many, or what the age range is in the population. So what do you think this graph is telling us about the population of Kenya? A large percentage of the population is young. Right? A large percentage is very young, and if we try to find an age, I could say for 10 and younger, I have 17 plus 15. 32% of the population is below 10 years old. That's very significant. Why might we want to study the data represented by this graph? It tells us about Kenya. It tells us a lot about Kenya. Sorry, spelling. It tells us a lot about Kenya and any challenges that Kenya might have. When your older population is a small percentage, they're going to have a hard time taking care of the younger generation. So if most of the population is 10 years old or younger, it's hard to provide for that young population when the older population is so small, because those are the ones that can work and care for and fix and build and prepare food. So there's a lot of challenges based on this population and the demographics. It may lead to finding reasons why the data is so skewed. It could lead to ways to help the population grow. Based on your previous work with histograms, would you describe this histogram as representing a symmetrical or skewed distribution? Explain your answer. And again, if you don't have previous work with histograms, now is when you're learning about them for the first time. You just have to really lean in and pay attention and ask questions if you don't understand. This I would also say is skewed. You know, it has a tail on the right. There is no mounding. Following histogram represents the age distribution of population in the United States in 2010. Here it looks pretty even until we're at 60 years old. That's pretty even. So what do you think this graph is telling us about the population in the United States? The percentage of population is pretty even. It's the same in each interval. All the way up to, I'd say, 60 years old. After that, the percentage does decline. Sorry. Why might we want to study the data represented by this graph? So population is used to determine health challenges, just like in Kenya. I mean, this population information can actually tell a lot about anything. Goodness, you know, restaurants could use it, shopping, cars, you know, employers could use it. You just have to come up with a reason and then give the reasoning why. Why do you think so? That's what statistics is all about. It's about telling a story. So population data is used to determine health challenges or education. That's another good one. Education challenges. Insurance companies use this for the health reasons, etc. Insurance companies. Okay, now into the box and whisker plot, Boxplot. 30 students from River City High School were asked how many pets they owned. The following box plot was prepared from their answers. Remember, we talked about each piece of a box plot is 25% of the data. So that right there is 25% of the data. 25% of the data. Need a different color. 25% of the data. 25% of the data. And we'll get to this little guy later. So each piece is 25% of the data. 30 students from River City High School were asked how many pets they own. The following box plot was prepared from their answer. What does the box plot tell us about the number of pets owned by the 30 students at River City High School? 30 students, students, so I've got 15 students are going to be 50% of the answers, and 15 will be the other 50%. So we really could say %50 of students have between 0 and 2 pets. And then we could say that 15 students have let's see, that would be between 2 and 10 pets. And the crazy thing is, we could also say sorry, I'm trying to work through my markers. 15 students have between 1 and I'd say about 5 pets. So it's sort of silly, like this is 50%. You know, the whisker and this box are 50%. The whisker and this box are 50%. Each quadrant of the box plot represents 25%, and 2 25s is 50, right? Next question, why might understanding the data behind this graph be important? I don't know, if you wanted to plan a pet day at school, you know you'd have most students would be involved. Most students would have a pet. Most students would participate. Yeah, it's just understanding your students, right? All right, one more box and whisker plot. 22 juniors from River City High School participated in a walkathon to raise money for the school band. The following box plot was constructed using the number of miles walked by each of the 22 juniors. So if we have 22 juniors, that means 11 juniors, that's half of the group. And they walked between 4 and, you could say, approximately 9 miles, right? So 50% of the juniors, which is 11 of them, walked between 4 and 9 miles. You could also say that 25% of them walked between 1 and 4 miles. And you could say that 9 and 11, approximately, were walked by the other 25%. What might understanding the data behind this graph be important? Again, you could talk about participation. If you're trying to raise money and do a walkathon and people are walking, like paying so much per mile, the history of that might be nice. I know if I'm sponsoring someone, I want to know, well, how many miles are you planning on walking? Because I might give more if they're walking a fewer amount of miles, or less if they're walking more miles. So sponsors may be interested in this information. I can't think of anything else. All right, in closing, when we're talking about statistics, we're talking about data, right? It's a story. It's a story given by a graph. When you're talking about your story, you need to back up or support any claims you're making. What else? I think that's good. Nice work.